Our setup for the lab, we have our laser here, our Shack cube here, our long focal length reference mirror here, and our viewing screen over here. And so we have our two beams, our reference beam that comes from the reflection off of this. So we blocked this mirror at first and found the focus over here where the reference beam focuses. We then exposed this mirror and found the that focus as well and lined them up so the centers of curvature were matched up. This beam had much more power than the reference beam, however, so we attempted to use a polarizer, placing it here in order to attenuate it a little bit, but that created other problems because the size of the polarizer is not the same as the size of this, so we were chopping off parts of our beam, which led to unwanted effects over here. This lens is a relay lens because the focus from the back reflection of the reference beam is too close, so we needed to move it out further, so we added a lens here.
So this is how the Shack cube works. We have incoming light and it's reflected off of the front surface, the reference surface, and focuses back here. There's only 4% reflection because it's just a regular surface. The rest of the light goes in, reflects off this beam splitter, and travels through to a test mirror and is reflected back. And what we want to do is adjust this tilt, the tip, tilt, and defocus on the test mirror so that the beams overlap. So this is a comparison of what we were doing last week to what we did this week. Last time we used a shear plate interferometer, so we had a wavefront and then the shear plate shifted it, and then we looked at the difference between the same wavefront shifted and interfering with itself. This week we have a reference wavefront and a testing wavefront, and we're looking at the wavefront between those two. This is what we expect to see in our interferometer drawings. So at null there should be nothing, just a bright spot. At defocus there will be rings, and the more defocus will cause smaller fringe spacing and more fringes. And then tilt will just shift this over, so the fringes don't change, they just kind of move over.
This was our null fringe we obtained in part C of the experiment. Well, we're not showing it going through to focus because our mirror is extremely touchy, and even slight adjustments would cause the fringe to disappear from the spot. You can see if I move the table.
For the next part of this lab, we've returned to the null fringe. It's a little bit decentered, so we already have a little bit of tilt in our system. There aren't very many fringes present, and it's a little bit difficult to see, but you can see that our null fringe isn't exactly circular. It looks sort of like there's a little bump on it, and that could be due to what we think is a defect on the mirror's surface, maybe a little ding or maybe just a little fleck of dirt, but overall it's pretty circular, and this seems not to be caused by something like an aberration, just some dirt. If we add a little bit of tilt, I'm just touching the mirror right now, and you can see that the spot sort of wiggles around and now it's gone. So this is really sensitive to tilt. Alright, so I found the fringe again. As you can see, just a tiny bit of tilt adds a lot of movement to our central fringe, and it kind of moves it around. Right now we're moving it in the X direction, and so it moves back and forth in the X direction. If you expect, if we moved it in the Y direction, it will go up and down, as you'll see, but it doesn't seem to affect the number of fringes that we see, other than that as you move it up you can see more fringes on the bottom, and as you move it to the side you'll see more fringes on one side. We would have a lot of sensitivity to tilt because we have, obviously because we're having a very long focal length mirror, and so that's why by even barely touching the mirror stand we can get a lot of tilt added to the system. These are the fringes that we see as we defocus the mirror. So we start before, and this is our null fringe, and then we're coming back and adding more defocus. You can see that our null fringe is not perfect. There's some splotches, and that's most likely due to defects in the mirror's surface, dirt, and other defects within the system. This is our fringe pattern when we have defocus and tilt. So you can see that we have significantly more fringes visible, and they have a much smaller fringe spacing. That's indicative of defocus. We also have our central fringe off to the side, so we have it tilted along the vertical axis, and so it's moving in X. And we aren't even touching the table right now. Just me talking is actually causing the fringes to move just a tiny bit.
So for this part we have both the focus and tilt, but we are only changing the defocus. And now we are doing the opposite, where we have both defocus and tilt, but we are adjusting the tilt of the mirror.